Hello everyone. Today I will introduce the power of data orchestration. There are four parts: storage states, storage acceleration, storage servitization, and the future plan. I will introduce the storage states and the storage acceleration. Let us see the architecture of our big data. The button is storage. We have HDFS and Ozone. The computer engine and the resource schedule is Spark, Flink, and Yarn, and Presto. There are also some app directed to us, such as search recommendation. And we also have a platform product called DMP. Let us see some metrics. This is about HDFS. The number of loads is thousands. The storage capacity is hundreds pp. The number of files is billions. The master QPS is hundreds of thousands. This is about Presto. The number of loads is thousands of incidents. The TP19 is about 2 minutes. The input is thousands of pp per day. The number of queries is hundreds of thousands per day. But the HDFS is unstable, and the Presto is unstable too. We can see the concurrence sometimes is about 10,000, and the TP19 is about from 3 minutes to 30 minutes, and the user always asks, can queries run faster? We solve the problem also is as a catch. The Alluxio is can as a catch to Presto. This is Alluxio and Presto typical architecture. We can see Alluxio worker is deployed with some machine with Presto worker. The Alluxio mount HDFS and the Presto visit HDFS via Alluxio, and the cache is managed by Alluxio. But it also have some shortcomings. We must need a specific cache policy and read slowly from Alluxio and the first time. Let's move up to the part 2, storage acceleration. So how to solve the problem properly? We update for 3 parts. We add tags into the partition properties and customize cache police and load cache before using. Then queries access HDFS direct without tags. We descend cache management. Let us see the architecture of cache management. Cache management node, unload, and mount data from HDFS to Alluxio. And we have a hard table. We can depend the update policy to node table. We subscribe Kafka HDFS RD log. The event include delete and create. Finally, we set partition properly to HMS and also can clear partition properly. Then computer application can get a tag from HMS. We also supply some APIs to operate. Let us see one by one. The hard table. The hard table is partitioned by data. Is calculate the number of visits of table every day. Is from Presto query log to have table. The hard table is a have table. Let us see the HMS tag. HMS tag is a key value part. The key is catch. The value is the data center, Alluxio, EBG, and Alluxio name service. If partition exact, set property in partition property, else set property in table properties. The Presto firstly get information from HMS. When have a tag, then read data from Alluxio, else read data from HDFS. We can see an example. Let us focus on the partition parameter. The key is catch, and the value is the data center, Alluxio, EBG, and name service. We also supply REST API. They are pass, have table, and admin. The pass and have table have the same command, such as mount, amount, node, and query. We'll do some tests. That is about the performance and the effect. Must to 55%, but sometimes is only 3% improvement. We also do some community contribution. I have 6 modules, 2 work in place, and 1 fixed by Alluxio. The type is about Hadoop, command line, web page, name service, and metrics. Okay, that is all for me. Then my colleague will continue.
Okay, hello everyone. I'm an engineer from Shopee, Haoning. I will introduce the next content of storage servitization in this sharing. Tianbao has introduced the current status of storage in Shopee. And let's look at the problem from usage perspective. First, most obedient data is stored in HDFS, and the various development languages are used. In addition, compared with the component developed in Java, HDFS has not enough support for non-Java clients. In order to solve this problem, based on investigation of Alluxio, we provide the following solutions. The first one is Fuse for HDFS. In Fuse, you can access data as if you were accessing data in locally, and this is divided into 2 parts. Deploying on the physical server and deploying on the Kubernetes cluster. And the 2 solution is to S3 for HDFS. S3 supports clients in many languages, and Alluxio compatibility with S3 interface. You can use the S3 interface to access data in HDFS. First, let me introduce the solution of Alluxio-Fuse. Let's first look at what is Fuse. Fuse is a file system in user space. And Fuse is consisting of two parts, the kernel model and the user space daemon. Fuse brings great convenience to users. With the support of kernel model, developers only need to implement the standard protocol interface to have a custom file system. And the picture on the right, is an architecture diagram of a fuse. When a user requests a question, when a user perform a few operations in the mounted directory, a system call will be triggered, and the VFS will trigger, and the VFS routes these operations to the fuse driver, and the fuse driver will create a request and push it into the queue. The fuse daemon reads this queue from the block device and then perform user-defined operations. And next, we have a general understanding of Fuse. Let's take a look at how Alluxio-Fuse provides services. The Alluxio-Fuse service is equivalent to the fuse daemon. Starting the Alluxio-Fuse service is a mount operation. The method in libfuse will be called to register mount point and callback functions with the kernel performing an operation like the ls on the mount directory will trigger callback functions. We can look the ls command in the picture. The result is equivalent to the list operation of the Alluxio, like this. Next, take a look at how to use Alluxio. Alluxio-Fuse. When you use Alluxio-Fuse, you should make sure libfuse is installed, and then we need to decide how to deploy the Alluxio-Fuse. There are two approaches to deploy Alluxio-Fuse. Alluxio-Fuse can be launched as a standard process, independent from existing running Alluxio cluster. Another one is the embedded fuse. The embedded fuse has the exactly same life cycle as the worker process is embedded. And we need to know the two implementation of Alluxio-Fuse, GenI-Fuse and GenI-Fuse, and the default implementation is GenI-Fuse. Although Alluxio-Fuse supports the standard protocol, supports the standard POSIX protocol, but it is focused to the provide reading services because the current main usage scenario is AI training, which is a typical reading. not good for the random write support, and our services requirement may not only be reader requests. So this is a point we need to improve in the future in our company. After introduce physical machine deployment, let's take a look at how to deploy Alluxio-Fuse on Kubernetes cluster. You could also use CSI to deploy to mount a Alluxio-Fuse system into application container. CSI is a standard storage interface for container. With CSI, you can expose any storage system to your container. The picture on the right is a schematic diagram of how Alluxio use CSI. CSI part is at the bottom. We can see that some are maintained by the Kubernetes cluster. We focus on the parts on the left. This need to be customed by the developers. One is the CSI controller, which is the control side. Realize the function of creating, deleting, mounting, and unmounting. And another one is CSI is node server, which is the node that specifically mounts and unmounts. In Alluxio CSI, node server is deployed in each node because they use the daemon side model in the YAML file. Users can specify to use Alluxio-Fuse CSI service and the mount point when defining a PV to use application pod. When creating a business application pod, Alluxio-Fuse service will be started on the node server. Thereby, business pod can access ATFIs which mounted in the Alluxio. In this model, there may be multi-fuse process on a same node server. This can save resources. But if the node server has something wrong, all the fuse process in the same node server will all be restart. So it affects all the application containers use the fuse. Actually, at the present, this problem has improved. We can specify whether to start the fuse process in a separate pod when citing PV. And before using CSI to run fuse on a separate pod, we introduced the sidecar model. In sidecar model is that each pod will start an Alluxio fuse container like this. We start a fuse container and This Alluxio-Fuse container is used to mount the Alluxio directories, and these two containers can share resources such as storage and network with the application pod. So the application containers can access the directory mounted by the Fuse process. So we can know there are some summarize some filters. The first one is the independent configuration of pods. So this is high flexibility, and each pod runs the Fuse containers without affecting each other because they are in themselves a pod, so they cannot affect another. And each post process occupies a container, so the solution may consume more resources. We introduced the two approaches about how to deploy Alluxio-Fuse. So we and and we conclude with 3-point maintenance, resources usage, and independence. The physical machine deployment Fuse operation and maintenance costs is high because we cannot know what the Fuse is on, where the Fuse is on, and the resources occupied is normally the when you use a model to deploying the Kubernetes cluster is more convenient for users, but they may use resources slightly higher. And better independence may mean high resources use, but this is acceptable. In addition to this method that require a mount operation, we also provide another solutions to with our storage civilization using S3 SDK to achieve a unified access method. Let's first take a look at the S3 concept. Maybe all of us know this concept, so I can't introduce them in detail. This is about file concept, bucket, object key, and region. Let's continue to see how to use S3 SDK for our services. The picture on the is this. The picture on the right is a simple architecture, and Alluxio provides purpose services that is compatible with the S3 API. After starting purpose service, the client sends the request to the purpose service through the S3 SDK, and the purpose service parser it into an Alluxio request to access the exact date. But how is the date mapped? Let's take a look at. On the left, we can see that a directory named projects in the Alluxio is mounted to a directory named projects in the HFS. We can note that we can make the fields respectively in Alluxio and HFS. You can see that the path and what is mapping data in S3 concepts. We can look at this picture. On this part, you can know that the first live directory as a packet is like this projects, and the subdirectories and the few paths as a key like the others passes. And the right is a simple example of the two access dates using Java SDK. We can know that the bucket name is project and the key name is the other is the rest passes of the total of the whole path, and we can get the content use this SDK to request or get object request. This is so easy. After determining to use the process service, we find that there has no authentication. So we add the authentication function by ourselves. Let's look at how to add the function. The S3 SDK converts the request into a REST request, and the client generates signature based on request information and then put it into the request. We have added 3 parts to implement the authentication. The first one is parser. We added the parser to request. We add this parser to parser the HTTP request is sent by the S3 SDK client. The request contained ID information, and the secret is obtained from the secret minder. We can is there. We can get the secret through the secret access ID, and the final use the validator to check if the signature is equal to the signature brought by the requester. And the figure on the right is the step to calculating given by the Amazon website. Is the process of passing requester and calculating the signature. We can see is use the interpolation algorithm to get three parts. Canary requester, string to sign, and signature. And then there's a signature after final, and there's a final signature after the final encoding, like this. The two service method have we introduced, and so how do we use this method? You can take this picture this is a service architecture, and we've configured HFS cluster as a Alluxio and storage service system. And the orange part, three orange part, is as a client. The users can choose any client they want to use to access data. And in the process of using Alluxio, we also found some problems and actually feedback to the community. We can take a look at. There are some problems with these PRs are committed by me ourselves. One is two PRs are about privacy, and one is about the Fuse, and one is about the CSI, and there are three PRs about doc fix, and another one is about ozone, but is fixed by others. At this point, the work that has been completed at this stage has been reduced. Finally, let's talk about our future plans. In terms of storage speeding up, we will speed up Spark and How. Actually, we'll also connect Spark and How to Alluxio. And for cache manager, we will add adaptive caching strategies to achieve better cache usage. And for storage service, there are two parts. For the Fuse service, we need to improve to support more process interface according to our business users. And we will strengthen communication with the community to improve our CSI and use it better. That's all. Thanks.
All right. Thank you very much for the presentation.